Okay, so time to start. Last presentation of the day. I'll try to make this at least worth your while, since you stayed that late. Maybe just as a show of hand, how many of you are running their application on a cloud? No? Are you running an application on like ISP or some dedicated servers in some ISP? I see some people nodding. So the presentation is about the journey that we took at eBay for the ebay.com site, moving our property to a cloud-like infrastructure. So it's not like a public cloud, it's private cloud. It's something that we do for us, right? But we went from, when I joined, it took a developer around a few weeks to put a new application on the site, and we brought that time to 45 minutes. So hopefully, what I'm going to describe will be helpful for you, either if you plan to move to a cloud or you are using your own infrastructure, but at least when you design your application and your infrastructure, you will be able to see things that did not work for us when we wanted to move to the cloud. So let's jump into what is eBay. So I'm not going to go through all the numbers, but there's key elements that we had to take into account when we design our cloud. The first one is the scale. You see from the various numbers that eBay is a very large site. There's, just for the front end, around 6,000 servers. A lot of people think that we have that many more servers to serve our ebay.com site, but that's a very efficient infrastructure, and we only need 6,000 servers. The other aspect that we had to take into account is the availability. So if you look at the numbers, we have 62 billions of goods sold every year. So that translates into around $2,000 per second. So if the site is down 1 second, it means that our sellers may lose $2,000, right? So that's very important. So that's two elements that we had to take into account. The other element is that we have an infrastructure that has multiple environments. So I talked about the front end. So that's the servers that are serving the ebay.com pages. There's our search infrastructure that is used for indexing and serving queries that you perform on the search box on the site. And then there is the analytics and data analytics site, which has around 9 petabytes of information. And we process every day, I don't remember exactly the numbers, but it's terabyte of data that is processed and then reduced into some few terabytes to be archived for a long time so that we can do analytics on it. So 3 different environments. So when we look at that, we start to see that there's a cloud that we need to build that has all those environments, or that support all those environments. But also, the other aspect is that we also have different class of service. So if you look at the site, there's always production traffic. Then there's going to be PCI compliant islands. There's going to be QA happening on the site. Research. Skunkworks is like our experimentation type of infrastructure. So we have to be able to have a cloud that, even if it's single tenant, because eBay is a single entity, single corporation, we still have to have something that supports multiple tenants, even if it's logical. The other aspect is that while we build this cloud, we have to look at all the other properties that eBay has. So today you've heard about X-commerce. Just that there's no confusion. X-commerce is not using that cloud. They have different problems, and they are going with another technology. But there's additional what we call adjacencies, like Kijiji, Rent.com, Alf.com, which are running their own infrastructure, and ultimately we would like to make sure that they could also run on the same infrastructure. So even though eBay is a single company, And we are building a private cloud. The problems that we had to solve are very similar to a public cloud because we had to support different type of quality of service, different type of applications, search application, data analytics application, front-end application. And we had also to support different geographies or different application altogether. Like, for example, StubHub application is very different than the eBay.com application. So all of that makes our cloud, even if it's an internal cloud, very similar to a public cloud. The only kind of difference is that we kind of trust people that are working for eBay and that are using this cloud, so our security is simplified compared to a real public cloud. So why did we build a cloud to start with? So the main thing that happened is over the past 10 years that eBay has been growing, we accumulated a lot of process. So that process is mainly aimed to protect the site, right? Protect the availability of the site, protect the PCI data that might be stored on the site. So for example, the type of process that we had is in order to release an application, you had to call the NOC. The NOC has to say, okay, you can release your application and so on and so on. But at the end of the day, what happened is that to release an application on the site, there was a lot of tickets that developers had to open. And they kind of complained that this was preventing them from being agile. The business was saying it takes too long, like I mentioned, several weeks to release a new application. And the productivity of our developers is not good. So we basically hidden those processes in a cloud. So that's the main value for us at this point. We want to give an experience to the users, the developers at eBay, that is similar to the experience that you can get if you go to Amazon or that you can get if you go to Azure, Microsoft Azure. So you don't slide your credit card, but similar to what you would do on Amazon, you open an account. You get your capacity and you deploy your application on top of it without any tickets or process getting in the way. So that's what they wanted. The other aspect that we looked at is efficiency. So it's more like a side effect for us. But if you look at that picture here, you'll see that that's real traffic. So it's the server utilization for the November week of 2009, which is the Black Friday week. And you can see that even during that week, we still have some spare capacity that we use for disaster recovery. So if we lose a data center, the remaining data center should be able to take over the traffic from the data center that has been lost. So we still have this buffer that is built in, but you see that we have daily peaks, we have weekly peaks, and that's the big seasonal peak that we have for the Black Friday. And there's a lot of white space. So how can we leverage our infrastructure and increase the utilization such that we have less white space? So one option is to fill out that white space with some other applications. So less business critical application, maybe like QA, or maybe we can shift some processing that, like batch processing, we can shift it during the time where the traffic is not peaking. So there's multiple strategies that we can look at to fill out that white space. The other strategy that we can also look at is, can we burst that traffic to a public infrastructure? Because since we need that capacity only few times of the year or only when there's a disaster, maybe we can switch that traffic to a public cloud and rent the capacity that we need only for that period of the year. But how much should we rent, right? Or should we all go to, move all our capacity to the cloud? So what we did is we built a model that is giving us the number of servers that we should keep on our infrastructure versus the number of servers that we should move to a public cloud based on our traffic pattern, right? So it doesn't work for everybody. It's just because we looked at how many servers we need at every time of the year and how many hours are in the peak and translate that into those curves. So what it means here, for example, is that even at 4 times the cost of a public cloud compared to our internal cloud, internal infrastructure, right? If the public cloud is 4 times more expensive, since we need the servers only part of the year when that peak is happening, we could move around 3,000 servers to a public cloud, and it would still be cheaper for us than owning those servers if they are not utilized most of the year. So it's kind of intuitive. In the same way, for example, if you need a car only a few weeks a year, it's cheaper to rent it than to buy it, right? It's kind of the same principle here. What we wanted to know is at which point do we own the car versus rent it based on how much we are going to use it. So that's the model that we are using. The variable is how much is a cloud going to cost us, a public cloud, because there's like the CPU time, there's the network traffic that you have to take into account. So we built a model based on our utilization in order to know what would be that sweet spot. And we looked also at our internal cost to see what was the best strategy for us. So that's something that you want to keep in mind, is that there's some scale where owning the servers is making sense. There's additional complexity, but that's something that we found is that for us, moving everything to the cloud was not cost efficient. So especially, well, except if the cost is very low, right? If it's like 0.5 of our internal cost, then yes, we can still save money if we move everything to the cloud. But when it's above one time our internal cost, then it's not efficient to move everything to the public cloud. So what kind of other decision did we have to make to build this cloud? So the first one is going all private, going public. So I talked about the cost aspect of a public cloud. Obviously, you've seen that moving everything, if the cost is above our internal cost, is not cost efficient. But there's also some other constraints that you have with public cloud. A public cloud is going to constrain your architecture. So for example, one of our customers, the search backend infrastructure, was asking us to have physical servers. Well, today there's no public cloud that is going to give you physical servers. The best that you can find is maybe Amazon that has those HPC servers, which are very close to the physical server. And maybe that's sufficient for some of our use cases. We did not try that. But for our immediate needs, we had to kind of be able to supply physical server or virtual servers. So only going to a public cloud did not work for us for those reasons. There's also limitation in what you can do on a public cloud, like for example, multicast is not going to be available on public cloud. So what we looked at is, okay, we need to have a private cloud because of agility and those requirements. But at the end of the day, what we want is also be able long-term to benefit from all the innovation that is going in public clouds, and maybe in the future shift all our infrastructure to a public cloud when it makes sense from a cost perspective. So we have a strategy which is, let's today have a private cloud with private infrastructure, owned infrastructure, keep an eye and experiment with public cloud, and you have heard about our experimentation with Microsoft Azure, and try out what they are doing, and see how the public cloud is evolving, how that capability and how those architecture dependencies that they built in are relaxed, or if we can accommodate those architecture constraints. So that's the first choice. The second one is, do we build or buy? So today there was a presentation from the OpenStack VP, which is a solution for building your own cloud and hosting it. We started the project almost 2 years ago. OpenStack did not exist, so we developed our own stack. We have what we call an abstraction layer, like a federation layer, that is able to work on top of public cloud, private cloud, and that is independent of the automation that is built under, so we can switch over time if we want the implementation. So what we decided is that we are going to build the software ourselves, because at the time there was nothing available. Keep an eye on what's going on, especially in the open source. Look at what xCommerce is doing with OpenStack, and work with OpenStack and the other open source projects in the cloud space to build this infrastructure, that automation that we need. So I mentioned a bit about what is happening with the public cloud. There's an additional complexity when you go with a public cloud, which is there's two flavors, if you want. There's one which is like a virtual private data center, which kind of keep all your applications hidden from the internet, and it's more like an extension of your private infrastructure. And usually, like it's called like private data center or virtual private cloud, depending on the vendor. What's happening is that they bridge your network and the network that you have on the cloud, and you have access through this kind of VPN or private peering network between your internal network and the cloud network. So that's useful if you want to have like backend services that you don't want to expose on the internet, but you still want to move them to the cloud. The other model is just the straight cloud model where you deploy your application and it's directly available on the internet. It's a completely isolated environment, and you benefit from all the other cloud properties like scalability, cost, and all of that. The virtual data center is kind of different costing model because it's more involved from the cloud provider. So you don't benefit from all the nice cloud pricing structures, but it gives you more flexibility if you want to have like a private entity on the cloud. So I think that over time, most people will run the two together. So I think that, for example, Netflix has part of their infrastructure that is going to move to a virtual data center kind of model for their backend. And the front end, what is serving their API is on the public cloud type of model. So I think that you have the flexibility to have both, but likely most people will end up with a combination of the two, especially if you have an internal infrastructure, because there's some complexity into. So ideally, you don't want to have a situation where you have part of your application on your infrastructure and part of the application on the public cloud. It's kind of creating a lot of issues in terms of latency, security. But if that's something that you need, the only kind of solution to bridge the two networks together is a virtual data center or virtual private cloud. So that's an aspect of moving to the cloud that has to be considered. The other aspect is the automation, right? So if you are running your own data center, or even if it's a small data center, and you are looking at doing automation, the products that you will find, now you find more and more cloud-enabled products, but the big four vendors of system management tools like BMC, CA, IBM, HP, they have those cloud-branded products, which are, in fact, they are legacy products that are rebranded for cloud, but they are not really what we need. So if you look at the verbs that they are using, they talk about service catalog, CMDB, ticketing, runbook automation, chargeback, server virtualization. It's those type of verbs. When we looked at automating our infrastructure to build a cloud, we found that we need a completely different breed of tools. And if you look at the verbs that you hear for managing a cloud, automating a cloud, you have REST APIs. You don't want service catalog. You want everything that is available through REST APIs. You want to have a tight loop for managing your infrastructure. So for example, when you are virtualizing a server and you are offering this server through an API, the customer should never see that the server failed. So you have to have a closed-loop remediation system, which is making sure that that server is going to always be available, that is monitoring that server and keeping that server up. So it's a much closer loop that you have to implement than ticket-driven automation, right? There's a notion of distributed state management, because when you have a cloud that is distributed across, like 4 data centers in our case, you have entities that are managed locally, entities that are managed globally, but what you want is that the state of all the entities are going to be available uniformly, because our applications are deployed across all those data centers. So we have to make sure that from the top, we have a global view of what is happening. So the problem of managing the state of those entities is much more complex. And today, there's not a lot of solutions out there that are going to provide you with this distributed state management. Instead of chargeback, people want pay as you go, right? You slide your credit card and that you are charged for what you are using. It's kind of the same system under the cover, but the philosophy is a bit different. And instead of talking just about server virtualization, you have also to look at network virtualization, service virtualization, storage virtualization, because what you want is multi-tenancy, abstraction, and sharing of this infrastructure, right? So all of that has to be taken together and not just focusing on virtualization, like, for example, VMware virtualization, right? So you want to have a holistic view, and you want this infrastructure to be completely virtualized and shared and multi-tenant. So when you look for tools, keep in mind those properties, and my advice is don't fall for rebranded management tools that are looking like cloud but are legacy tools that are repackaged into doing automation for just regular infrastructure like an SAP application. That's not what we are talking about here. So what problems did we have also? When we tried to automate those 10 years of legacy applications that we built over time, we found that there was components that we had that could not be automated, or processes, steps in our processes that could not be automated. So obviously, like if you are racking and wiring servers, you cannot really automate that. But what we did is that instead of dealing with it ourselves, we had to deal with Dell or HP, and we told them we want to have racks that are already wired and racked and wired. So we receive a full rack with switches and servers connected. So we don't have to deal with that. The other problem with automation is that some components, like the checkpoint firewalls, could not allow us to completely automate the configuration of the firewall, adding new rules, because they always required someone to push some button on a UI in order to push the rules. So we replaced those components, making sure that we can automate everything, right? So everything has to be automatable. And when we go look for components, that's one of the criteria that we are using is, do you offer REST API, do you offer SOAP API, or what's your automation strategy? Can you do everything through an API, right? The other problem that we found is that some tools that we were using are configured through files. So if you think about automating a tool that is using a file for its configuration, you see that you cannot have multiple entities modifying this same file. So you have to have like a lock. For one entity modify the files, then another entity modifies the file. And at some point, you need to tell the process, reload your configuration, right? So for example, ISC DHCP is a good example of that. In order to change the DHCP configuration, you have to edit the configuration file and tell the DHCP process to reload the file. And you cannot do many changes because of those logs that you have to build in. So we also are looking at replacing those components with tools that are directly configured through API and not going through a file in terms of API for configuration. So the other issue that we had with automation, and it's more like an organization issue, and hopefully you don't have this problem, is that when you have a big company like eBay, we build silos. So you have people that are responsible for networking, people that are responsible for security. And usually they have those rules like separation of duty, where someone cannot change the network if they are not from the network team, or you cannot change the firewall configuration if you are not from the firewall or NetSec team. So we had to deal with that using another mechanism, which is that we ask them, okay, that's fine. If you want, you offer us a service so that we can change the configuration of the switch, or you give us a service so that we can tell you when to change a rule. But ultimately, we want to make sure that the automation is kind of a system by itself, and that all those components are integrated much more tightly. So it's kind of a short-term goal to be able to talk to them through APIs, but at some point, ideally, everything should be controlled by the same system. Now, the other aspect that we had to look at is the application architecture, and that's maybe where you may make the most mistakes. When you want to move an application that was developed on your own infrastructure to a cloud, there's a lot of you're making assumptions about the infrastructure when you are developing your application. So some of those assumptions that you may make is, for example, layer 2 adjacencies. If you have an application that is discovering peers using some broadcast protocols, or if you have a web architecture using a load balancer where you have what we call two-arm load balancing, where you have all the traffic, like the default router for your server is the load balancer. There are some application that server and load balancer are in the same layer 2 network. So those applications, those expectations are making the migration from your private infrastructure to a cloud much more difficult, because the cloud is not going to guarantee you anything like that. Your application will be in a different IP space from each other. You cannot say, for example, all the instances of my application are going to be on the same subnet, and they are going to be /32 or 30 or /23 or something like that. So, for example, building firewall rules are going to be much more difficult. Identity also is not going to be assumed from the IP, because like you see, for example, in Amazon, every time you restart an instance, you have a different IP. So you cannot assume that your instance will always be identified by this IP. And that has also implications. We are looking at eBay, we take for granted like scalability and availability. But the only thing that we missed is is the agility. So like there is a few things that we did wrong. One was, for every phase of our life cycle, we had to rebuild the application. So for example, when we wanted to QA the application, we built a QA version with the strings pointing to the right services. Then when we wanted to deploy to production, we were rebuilding the application for production. So that is causing issues, because the bits that you are building for QA are not the exact same bits that you are actually running in production. So you still have to have some phase of validation at the end. And we kind of tied together the code and the configuration, which is very bad practice. The other issue that we had was that our code was very monolithic, if you want. Not so much the code, but like the packaging. We built this gigantic zip of everything that an application needed, like the container, the JVM, the shared library, and then the application itself. So it's very good because you test that bundle and you deploy that bundle in production, so you are guaranteed that all the bits are going to work together. But that has some issues, because now you are moving this gigantic bundle every time you want to deploy just one jar. And it's the same problem, for example, when you go to a cloud like Amazon. Is it better to build an AMI every time you want to deploy an application? Or is it better to have an AMI that is identical across multiple versions of your application, and then you deploy your application on top of that AMI? So that's a choice. I don't think that we have a good solution for that yet. What we are still looking at ease of testing and agility. There's pro and cons in each case. But we are trying to build applications that are much more modular, so that we can make that decision if we want to. So the first thing that we did is build cloud-friendly application by decorrelating applications from capabilities, if you want, and build services based on SOA, which would have like an ESB type of bus between them, and the endpoint in that case are dynamically configured. The configuration is also kind of a lead binding that is happening either dynamically. For example, an application can discover what are the backends that should be used for its persistence, or what are the endpoints for this data center, for this service or that service. So that's the first phase that is still ongoing, plus the modularity that I just described using OSGI type of containers. But going forward, what we want also is migrate out of kind of our dependency on Oracle. So what happened is that we have a very good persistence abstraction layer, data abstraction layer, that make it very easy for developers to put their data in Oracle, and it's automatically sharded and available and scalable. So by default, even if you need just a table of key value pairs, what developers were doing, they were putting that in Oracle because it's available, right? It's easy, and it's always there. But so what it means is that now if we want to move to a public cloud, we have to look at the data and move the data together, and Oracle is not the best persistence for moving to the cloud, right? If you want to move to the cloud, it's easier to have like simple key pair type of store or NoSQL type of store. So that's something that we are looking at. We'll never remove completely our dependency on Oracle because eBay has a kind of these big requirements that since we are doing financial transactions and every e-commerce will have the same kind of requirement, you cannot put everything in like a NoSQL database and hoping that the transaction will succeed and that the data will always be there, right? So we still have those criteria for the database that makes us like Oracle for some use case, but for the other use case where we don't need that those guarantees, then it's easier to move those data to like NoSQL or key pair type of stores. The other issue that we had to solve is over time, every application kind of got their own custom infrastructure. So it might happen to you even if you have like a small deployment, because you deploy your front end and your database and you say, okay, I'm going to buy those servers with that much memory and that much disk for my SQL database, and then I'm going to buy another type of server and another model, and maybe it's cost effective to do that when you are limited in resource. But when you look at the impact is that if you need more resource for your front end and you need more resource for your back end, you cannot swap out those resources, right? They are dedicated now. You have one model for front end, you have one model for back end, you have one model for this type of application, one model for that type of application. And this was happening to us. We had custom settings in load balancers, custom servers, custom networking setup per application. So it was very difficult, for example, to move a server from one application to the other one, to the point where we even had to rewire the servers if we were going to do that, physically move the server. We could not logically move a server from one application to the other one. So we also saw that you saw that white space that we had in our infrastructure, right? Each pool had their own kind of spare capacity, and you could not share that capacity between other applications because I mentioned that they were kind of custom designed for each application. So you could not, like, if you had no more resource in your secure environment and you had a lot of resource in your non-secure environment, then you could not move that capacity unless you use the forklift and moved from one location of the data center to the other one. So we moved to more like a virtual infrastructure that is shared, where we introduce the notion of global pool of resource, and everybody deploying on top of that infrastructure would draw resource from that pool. And you will see what's the impact of doing that. So when we started, an application developer would request a server, provide the name of the application and the type of servers that they wanted. Then we would order the servers from a vendor. It would take 2 or 3 weeks for the servers to be delivered. Then there was the process of racking and wiring those servers. And we were putting the name of the application on the label, which is very bad. Then 1 week after, we would give the servers to the developer, and the developer would deploy the code, and the server was up and running, and the application was up and running. The repurposing of a server from one application to the other one, because we put that name on the label, would mean that we had to go back all the way to racking and wiring in order to move a server from one application to the other one. With the new process, what we did is that now we are ordering those servers quarterly by rack, right? So the rack are coming already, the servers are coming already rack and ride. So we have to order a bit more, right? We have to be very efficient in terms of capacity management. Then they would arrive using the regular 2 or 3 weeks. But at this point, they are put into that global pool, that cache of servers. So this has a cost because you have some capacity that is not used that is going to stay for a while in your cache. But then when a developer comes and says, I want 5 servers for my new application, it takes actually 45 minutes to deliver those servers to that developer because they are already there, already rack and wired. The only drawback is that the developer cannot specify a model. The only thing that, because it's part of the cache, right? All the servers look the same. So it's less efficient for some people because you might get a server that is more powerful than what you need. But with virtualization, we can slice those servers such that we don't lose that much capacity or we don't waste that many resources. So that's the bottom line for and what helped us go from several weeks to 45 minutes. So I mentioned before OpenStack and open source and build versus buy. So if you look at the stack that we have built for automation, we have a bottom layer that is kind of our hardware abstraction layer that is talking to our infrastructure. And on top of that, we have all our applications that are like providing the resource that are exposed through IaaS or PaaS layers. So over time, what we will do is contribute what we have that is missing, for example, from OpenStack or other open source projects, and adopt the remaining components that we can leverage. But there is still some issue in terms of focus. So if you look at an OpenStack project, for example, usually people have like maybe 5-10 servers in a project, and that project is directly exposed to the internet, and it's a very different infrastructure than, for example, eBay, where we have 200 type of applications, 200 applications, and one application might have 500 servers, and those have to talk to each other much more than an isolated project. So there's kind of an impedance mismatch between the design point of a cloud that is built for an ISP, like Rackspace or some other ISP vendors, and what we need internally, where we have larger environments that need to interact a lot, and we cannot go to a lot of network layers, otherwise we have issues of scalability and latency. So for those use cases, we may not be able to leverage a lot of the open source technology, but we have some other use cases which are fitting very well for open source type of cloud, which is like for experimentation or QA, where you have few servers and you want to expose that directly to the internet. So that's it for the presentation itself. We have time for Q&A. If you've not seen that before, there's still some opportunities to register for this event tomorrow. The information is on the Eventbrite site, so you can register with the password pxforward, and you will be able to get a lot more hands-on on some of the technology that you've seen during this conference. Questions?
I think we only have time for a couple of questions.
Have you had to, separate your clouds into web serving type, a web server type pool and just a server pool, with the web server pool being, having the ability to serve Apache and the other, not running Apache?
So the way we do that is we have two layers, if you want. We have one layer which is infrastructure as a service, and this one is going to be similar if the application, the server is going to for front end or for our search backend, for example. Then we have another layer which is platform as a service, and that layer is the one that understands the application. So we have specific processes for front end pools and specific processes for database pools or search nodes. And those processes will know what they have to deliver on those servers. So it's a kind of a two-tier. At the top level, you're right. So there will be servers which will end up with Apache and front-end applications. And there will be servers that will not have any of that because they are search node, for example. But from the infrastructure point of view, they are going to be identical. So we have these two layers, which allows us to share the same kind of infrastructure between those multiple use cases. Because what we don't want is have those silos being built such that we cannot move capacity from one use case to the other one. So we need to be able to reconfigure easily and move capacity around.
What virtualization tool do you use?
So we developed most of the tools. So we even so we reuse some of the tools that other companies build. So for example, one example is the Twitter software deployment using BitTorrent that is called Murder. So we reused part of that to accelerate our software deployment. We improved on it and deployed it on our cloud for software deployment. But otherwise, just now, with the OpenStack community starting to grow much more and accelerating their deliverable, we are going to look at more tools that we can leverage.
Hi, I got a quick question which is non-technical. So this is a big change for any large deployment. So what about the layer 8? How was the general reactions to this change?
So there's two camps at eBay. There are people that used to do those operations manually and manage the infrastructure. And it's a big change for them because we are upsetting their world, right? They were DSA that were deploying servers and going through the steps. So they are starting to get on board because now they have opportunities to do something that is more interesting than racking and wiring servers. On the developer side, I think it's kind of adoption is much faster because before they were going through like 17 or 20 tickets to deploy something. And now they just go to a portal and they just enter their information and they click one button. So the adoption, like we have to push them out for saying, okay, not now, we're not completely ready for you, wait. So during the development, it was like one group was willing to accept the change much more like strongly than the other one, right? One was pushing out, the other one was pushing forward, right? So pushing back and pushing forward. So it depends which team you are talking about. One question in the back.
The last.
What do you do when you have deployments of new software? For example, in your infrastructure, if you have like search implementation A, and you have a new version, implementation B, and you need to roll it out in a live system so that A starts phasing out while B is spinning out more instances. How do you orchestrate something like that?
Right, so there's two options. One option is in-place upgrade. So what you do is you have a rolling plan for upgrading instances to the new version. So we do that for very large pool. Like for example, when we have a cluster of 5,000 servers that need to be upgraded, we do an in-place upgrade because we cannot like create another one of 5,000 just like that, right? So we have what we call an update strategy. So usually for our front-end pool, what we do is, for example, we change 10% of our code. So 10% of the servers will run the new code. 90% will run the old code. And we'll monitor the 10%. So we'll start with 1, 10. Then we may wait, for example, for 24 hours for the 10% of servers to get more traffic. We'll monitor the error rate, like type of errors and other conditions like capacity and all of that. If the build is clean, then we'll go to 100%. So it's in place. The other strategy is a swap, right? Black-white swap. So you create another instance. So for example, if you have just 3 servers, it's much easier to build another pool of 3 servers. Then you swap the VIP from the previous one to the new one. And you can swap the VIP gradually. So depending your load balancer, you can direct 1% of your traffic to the new pool, monitor if it's going correctly, and then swap 100% of your traffic to the new pool. Question? Okay.